Your objective for lesson 12 is I will solve word problems involving area. So we're going to be working with word problems today and still working with area. Okay, so our first problem says the area of Theo's banner is 32 square feet. If the length of his banner measures 4 feet, how wide is his banner? So what information is unknown? Remember when we're trying to find the unknown information, we always look at the sentence that has a question mark. So right there it says how wide is his banner. So what we do not know is how wide his banner is. And so we're going to use an area model and we're going to use a letter for the unknown. So since it's asking how wide the banner is, we're going to use the letter W whenever we're drawing our area model instead of a question mark. On this page, I just want you to take a look at the area model. So if the length is 4 feet and the area is 32 square feet, can the width be less than 4 feet? Because when you're looking at this picture, they're calling this side right here 4 feet, and they're calling this side the width. But when you look at this side and you look at this side, which side is longer? Okay, this right here is longer. So they're saying that this side would have to be less than 4 feet because since this side is smaller, it needs to be less than 4. But can you multiply 4 by anything that is less than 4 and get 32 square feet? No, you can't. So that's why sometimes I tell you guys to make sure your drawings are correct because your drawing really needs to represent what the rectangle looks like. And if you have 4 feet right here and your area is 32, then your other side length must be longer than what this side length is. So this area model is incorrect, and we know that because this side length would need to be longer in order for the area to be 32 square feet. So on your board, I want you to correctly redraw what the area model is supposed to look like for this problem. If we know that the area is 32 square feet, and we know that this side length is 4 feet, or even this could be 4 feet, depending on where you put it, we need to know what the other, or it does have to be on this side length, I forgot, because over here on the previous problem, we're trying to find this. Okay, so we're needing to find the width, but we know right now that this width of the banner is going to have to be a lot longer than the length of the banner because this is going to be a bigger number. So be thinking in your head right now of what can you multiply 4 with to get 32, or our division equation of what is 32 divided by 4. So correctly redraw what the area model should look like. Label the side lengths with 4 feet and the letter W since we're not sure what the other side length is yet. And go ahead and put what the area is inside of the rectangle that you're drawing. Whenever you're ready to check your answer, you can push play. Okay, so this is more of what the rectangle should have looked like. Okay, you can tell now that this side length is about twice of what that side length is, and that's kind of what we're looking for in this side length anyways, because it is going to be longer. So how do we find the value of W? And we just talked about that. You could have thought of multiplication, or you could have used division. The division equation that we would have done was 32 divided by 4 is equal to W because we're not sure what W is. So on your board, I want you to go ahead and write down what is the value of W. So what is W equal to? Okay, we know that W is equal to 8 because we know that when we multiply 4 and 8 together, we get 32. So this missing side length of the banner is 8 feet. So the width of Theo's banner is just 8. 8 what? We know that it is 8 feet. And make sure when we're working with area that we're including the unit that we're talking about. This wasn't inches, this wasn't centimeters, we were talking about feet. Okay, our next word problem, if you want to have your board cleared off and ready for this one. It says the area of a piece of paper is 72 square inches. Margot measures the length of the paper and says it is 8 inches. So what is the width of the paper? So on your board, go ahead and draw a rectangle that looks similar to this. Inside the rectangle, I do want you to put what the area is. It's 72 square inches. And we know that one side length, well, we know that the length, and the length is right up here, is 8 inches. So go ahead and label that on your board as well. And we're not sure of what the width of this paper is, but we're going to use a letter for the unknown. And since we're trying to find the width, again, we're going to use a W right here on the side of the paper for what we do not know, because we're not sure of how wide this piece of paper is. So make sure on your board that you have this. Make sure you still have some space to work, because there are going to be some other things that I'm going to have you add to your board whenever we're working with this problem. Okay, so once again, here's a picture of something that would not be right, because if this is 8 inches, then can you multiply 8 by anything that is smaller than 8 and get 72? Negative. So that's why we'd have to draw something that was more like the piece of paper that we had, and this is what you have on your paper right now. So go ahead and write the division equation that we would use to find what W is equal to. And then I also want you to put on your board, what does W stand for? What is W? So write the division equation that we need, and also tell me what is the value of W, how wide is this piece of paper. Whenever you're ready to check your answer, you can push play. Okay, so the division equation is 72 divided by 8 equals W. And if you already put 72 divided by 8 equals 9, that's okay as well, because that tells me that this W right here is equal to 9. So the other side length for this piece of paper is 9 inches. So the width of this piece of paper is 9 inches. Okay, moving on to the next problem, if you want to have your board ready. Amir is getting carpet in his bedroom, which measures 7 feet by 15 feet. How many square feet of carpet will Amir need? So we're going to draw an area model to represent Amir's bedroom, and we're going to write an expression that shows how to find the area. So when we look back up at the problem, it tells us side lengths of the rectangle where he's going to get carpet, but it doesn't tell us how many square feet of carpet he will need. And that right there is the area. If we're trying to figure out how many total square feet he needs, then we're trying to find the area. So for this one, it doesn't give us the area in one side length. It goes ahead and it gives us both side lengths, and we're going to have to find the area for that carpet. So on your board, go ahead and draw a rectangle to represent his bedroom. Make sure that one side has 7 feet, and make sure that one side has 15 feet. And remember, all of your sides on your rectangle don't need to be the same length, because if one side is 15 feet, that's more than half of 7 feet. So one side's going to need to be a lot longer than the other side because of the numbers that we're working with. Whenever you're ready to check your area model, you can push play. Okay, so your area model needs to look like this. If it was turned another way, that is also fine with me. So if you had it and it was turned like this, that's still going to be the same thing. Just so long as you had one side labeled 7 feet and you had the other side labeled 15 feet. And in the middle, or if you have it somewhere else written on your board, that's fine. But this is the equation that we're working with to help us solve the total area. So we're going to have to do 7 times 15. Now, we usually don't work with bigger numbers like this when we're multiplying, so we're going to have to use a different strategy to help us find the area for this rectangle. So we need to decide what strategy we want to use. And for this strategy, it's probably going to be a good idea just to break apart this number into its tens place into its ones place. So I know that this 5 is still a 5 because it's in the ones place. But this 1 right here is in the tens place, so I know that this is a 10. So I'm really saying that I'm going to be multiplying 7 and 10, and I'm going to be multiplying 7 and 5. Who can remember what property is this? Remember there's multiplication properties that we've worked on. What property is it where you break apart one of the factors to help you solve it? If you're thinking of the distributive property, you're correct because we're breaking apart this factor of 15 to make this easier to solve. So now we're going to have to figure out what 7 times 10 is and what 7 times 5 is. And then all we will need to do is add those two answers together to give us the total area for this rectangle. Okay, so on your board, I want you to write down these two equations, 7 times 10 and 7 times 5. And I want you to solve those two equations and then add those numbers together to figure out the area of this entire rectangle. Whenever you're ready to check your answer, you may push play. Okay, so 7 times 10 was 70, and 7 times 5 was 35. So whenever we have 70 and 35 together, we get 105 square feet. So the total area of the carpet that he will need, or how much carpet he will need, is 105 square feet. And you can see right here how they drew a line to break apart the rectangle. This does show that there are 10 feet on this side, and this shows that there's 5 feet. If they were to, let's say, draw a line right here down the middle, then I wouldn't be able to put 10 feet right here and 5 feet right here because that's not what it shows. So it's really important to make sure whenever you're drawing your rectangles that they look like they should depending on what the side lengths are. So sometimes when you have bigger rectangles with bigger numbers, just like we had with this one, you're going to have to use that distributive property to break apart the numbers to help you solve the equation and help you find the area easier. Okay, if you want to go ahead and take out your problem set so we can work through that and push play whenever you're ready. Okay, so number 1 says each side on a sticky note measures 9 centimeters. What is the area of the sticky note? Okay, so these are post-it notes, and you all know what a post-it note looks like. So for this one, I am going to expect you to draw a picture of just a rectangle. What does the post-it note look like? And it says that each side measures 9 centimeters. So we don't have to label all 4 sides because when we're finding the area, all we do is multiply the length and the width. So you just need to label 2 sides of the sticky note. And once you have drawn your area model for this sticky note, I want you to include a sentence to tell me what is the area of that sticky note. So after you've done those 2 things on your problem set, I want you to push play to check your answer. Okay, so this right here is what I was looking for. Once again, I said you didn't have to label all 4 sides. I was really just looking for 2 of your sides to be labeled, so you didn't have to have all 4 of them done. I forgot that I had did it that way, so I'll just go ahead and take off 2 of them. So we've got 9 here and 9 here. So the area of the sticky note is 81 square centimeters because when you multiply 9 and 9 together, you get 81. Make sure you had square centimeters in your answer whenever you wrote that in a sentence. Okay, we're going to move on to number 2. Stacy tiles the rectangle below using her square pattern blocks. Find the area of Stacy's rectangle in square units, then draw and label a different rectangle with whole number side lengths that has the same area. Okay, so you're going to have to find the area of this. Write the area of her rectangle in a sentence, and then I want you to draw another rectangle that has the same area, and it says use whole number side lengths. That's just using numbers. So make sure you're labeling your new rectangle with numbers for the side lengths, and make sure it has the same area of this rectangle. So this is kind of what we did back in the first few lessons of this module where we had to draw rectangles that had the same area. So whenever you're ready to check this, I would like for you to push play. Okay, so the area of Stacy's rectangle is 12 square units. And a new rectangle could have been like this, 2 units and 6 units. You did not have to draw it like this. Another way you could have drawn this was to take this rectangle, and you could have turned it this way to make it have 6 units and 2 units. Another way you could have done it was have a rectangle just like this one, but turned the other way. You could have also drawn a really long rectangle that had 12 square units in one whole row, or you could have had it going up and down where there were 12 square units all in a row. So there's many different ways that you could have drawn it, but this was just one example of them. If you had any of the rectangles that I just listed, then you would have been correct. I didn't draw all of the different squares in mine because you didn't have to do that. You really just needed to draw the area model and label the side links with numbers. So we're going to move on to part B. It says, can you draw another rectangle with different whole number side links and have the same area, and explain how you know? Well, I kind of just answered that for you by showing you all of the different ways you could have drawn a rectangle that had the same area. So go ahead and draw another rectangle and label the sides again and make sure it has the same area as Stacy's did, and explain how you know that it has the same area. Whenever you're ready to check your answer, you may push play. Okay, like I said, this could have been another one. It could have been turned up and down. You could have done one of the other ones like I just said, where you had this one and it was turned sideways. You could have had one just like this one right up here and it was turned sideways. So any of these would have worked as long as you were labeling the side links on them. And to explain how you know, I was looking for, I know the area is 12 square units because 1 times 12 equals 12. I was really looking for you just to explain how you knew that whatever you drew had an area of 12 because all you had to do was multiply the side lengths and that would have given you 12. So if in your explanation you explained to me how you multiplied the side lengths to give you your area of 12, then you're correct. Okay, moving on to the back side of the problem set. Says an artist paints a 4 by 16 foot mural on a wall. What is the total area of the mural? Use the break apart and distribute strategy. So they're using the distributive property because they broke apart 16 into 10 and 6. So we're going to have to find the total area, and it says use the break apart and distribute strategy. So you're going to have to solve it like you would using the distributive property. So you're going to have to solve it by solving 4 times 10 and then by solving 4 times 6 and adding those answers together to get the total area. So make sure whenever you're working out your problems over here on this white space that I see that you're working out both of the problems and that you're adding those answers together to get the total area, and then make sure that you're writing your answer in a sentence of what is the total area of this mural. So whenever you're ready to check your answer, you can push play. Okay, so I was looking for 4 times 10 and 4 times 6. I was looking for you to put 40 plus 24 because 4 times 10 is 40 and 4 times 6 is 24. And whenever we add 40 and 24 together, we get 64. So the sentence I was looking for is the area of the mural is 64 square feet. Okay, number 4 says, Elena tiles the figures below and she says, I'm making a pattern. Find the area of Elena's 3 figures and explain her pattern. Really what I want you to do, it doesn't matter to me if you draw these other 2 rectangles here. On your paper, if you would just go ahead and underneath these 3 rectangles, just write the area. What is the area of these 3 rectangles? Don't worry about redrawing it or trying to tell me what her pattern is because I'm more worried about you being able to tell me what the area of these rectangles are. So go ahead and write down what is the area of these three rectangles that you have on your problem set, and whenever you're ready to check your answer, you can push play. Okay, so this one was 4, and I forgot that I had them at multiplication equation, so it was 4, and it's not just 4, but it's 4 square units. So if you need to adjust your answers over here to make sure that they include square units, make sure you go ahead and do that before we move on to check the others. Okay, so this rectangle had an area of 9 square units, and this rectangle had an area of 16 square units. So we're going to go ahead and we're going to just move on to number 5. This says Jermaine glues 3 identical pieces of paper as shown below and makes a square. So this right here is a piece of paper, this right here is a piece of paper, and this right here is a piece of paper. This is 3 pieces of paper, and he's got one big large square. Find the unknown side length of one piece of paper, and then find the total area of 2 pieces of paper. Okay, so if this is one piece of paper, we're going to have to figure out what is the area of this whole thing, and then we're going to have to do 2 of those. And we're also going to have to find what is the side length of just this one piece of paper. So let's think of it in the bigger picture. If this whole thing right here, this whole side length, which is the same as this side length, is 9 centimeters, and I have 3 different pieces, what equation could we use to find the side length of each one of these pieces of paper? I've got 9 as my total, and I've got 3 different pieces. What equation could we use to find the side length of just one of these pieces of paper? I want you to think about that. If you need to push pause, do that. Okay, so the equation that we're needing to work with is 9 divided by 3 equals 3, because we've got 9 here. There are 3 pieces of paper, so we're just dividing 9 in those 3 pieces of paper, and that's going to tell me what this side length on both sides of the paper is. So we're going to say that this unknown side length right here is 3 centimeters. So I want you to go ahead and on your paper, make sure you have this equation written. And I want you to go ahead and write a sentence that tells me what the unknown side length of one piece of paper is, because now we have figured out that it's 3. So push pause and get that down on your paper so we can move on to the next part of this problem. Okay, so the sentence I was looking for is the missing side length is 3 centimeters. Now we have to find the total area of 2 pieces of paper. So we are needing to find the area of this piece of paper right here and this piece of paper right here. And if we know that this side length is 3, then that must mean that this side length right here is also 3. And we already know that these side lengths right here, these long ones, are 9. So to find the area of one piece of paper, what equation can we do? If I'm just trying to find the area of this one piece of paper, what equation can we use to figure that out? I want you to go ahead and write that on your paper so I know how to find the area of just one piece of paper, and then that's going to help me to find the area of 2 pieces of paper. Whenever you're ready to check that, you can push play. Okay, so I know that one piece of paper is going to be 3 times 9 equals 27, or you could have put 9 times 3 equals 27. So if one area right here is 27 square centimeters, then I know that this piece of paper also has an area of 27 square centimeters because they're the same exact piece of paper. So now what equation can we use to help us find the area of both of these pieces of paper if we know that the area of both of them is 27 square centimeters? So now I want you to go ahead and write that equation that we're going to use to find the area of both of these pieces of paper. And whenever you're ready to check that, you can push play. Okay, so we would be working with 27 plus 27, and that would give us 54. So now we know that the area of both of these pieces of paper right here are 54 square centimeters. So go ahead and write a sentence telling me the total area of 2 pieces of paper. Whenever you're ready to check your answer, you may push play. Okay, so the total area of 2 pieces of paper is 54 square centimeters. Okay, moving on to the exit slip, there are 2 different questions. Make sure you're answering all parts of the questions and finishing both questions before you bring it to me to check, and whenever you're done, you may bring it to me.